Hello and welcome to Advanced Algebra. In this second video, you're going to be learning about the law of sines. So, what is the law of sines? So, we've introduced trigonometry with a right triangle, right? And we took an angle right there, and we said, well, this is the opposite of the angle alpha. This is the adjacent side of the angle alpha. And we have the hypotenuse, right? And we define the sine and the cosine and the tangent. This is the right triangle. We define sine, cosine, and tangent in function of the adjacent, the opposite, and the hypotenuse. Okay? But you were working in a right triangle. So up to now, trigonometry is done in right triangle. Well, the law of sine is what happens to trigonometry when you do not have a right triangle. Okay? Actually, there are two laws, the law of sine and the law of cosine. That will describe what happened to geometry when you don't have a right triangle. So, what does the law of sine state? Before we do that, I need to show you the labeling convention we use for a triangle. The labeling convention for a triangle. So let me take a triangle that is not a right triangle, like this one, for example. Let me call that side vertex A, right here, A, B, right here, and C, right here. All right. So this vertex, actually, the capital letter, will represent angle, okay? And I'm going to say angle A, angle B, and angle C. A vertex is a point. I am not interested in a point in trigonometry. I'm interested in angles, okay? So vertex A, B, and C. Now, opposite the vertex A, I will call this side A, and I will use a lowercase letter for side, okay? Opposite the vertex C, you will have side C with a lowercase letter. And of course, opposite the vertex B, you will have the side B with a lowercase. So this is the convention we use to label any triangle, okay? So what does trigonometry becomes when we are dealing with a triangle that's not right? What does the law of sine state? So it states that A over sine of A, side A, the length of side A over the sine of the angle A is equal to the length of side B, B, over sine of angle B, which is equal to length of side C over the sine of angle C. Angle C, of course. Okay, so it's A over sine A equals B over sine B equals C over sine C, and this is the law of sine. Okay, we will see that we also have the law of cosine, and these two property, these two law, is what happens to trigonometry when you don't deal with a right triangle. Let's apply the law of sine. Okay, so we'll see how to deal with this double equality here. All right, I picked the problem from math space, so you may encounter the same problem when you're going to be doing your math space task. So here we go. Find the length of the side A right here. Here's side A using the sine rule. All right, so this is the side I'm looking for. What does the law of sine state? It states that A over sine A, that's a sine of the angle opposite A, equals B over sine B. I don't need to write the third one, okay? We'll see what's going on, but I really don't need to write the third one. So this is going to be my angle A right here. And look, this is my second pair that is given. So I'm going to say, why not call that B? And this is going to be B right there, okay? It doesn't matter if you call it C. It really doesn't matter. It's going to be A over sine A equals C over sine C. It's really the same. So let's replace our label with the values that are given to us. So A, well, that's what I'm looking for, right? So A over the sine of what? Sine of A is 32. It's the angle opposite the side of A, the side we're looking for. Equals B, so 13 right here. 13 over the sine of the angle B, and that's 68. Here we go. That's how we use the law of sine. You see, everything is known except for A. So you multiply both sides by the sine of 32, right here, sine of 32 degree, and that will, here we go, multiply both sides by the sine of 32 degree, and that will isolate A. So that gives you what? So it gives you A equals, so A equals 13 over sine 68 degree times sine 32 degree, which of course this is like a fraction, right? So you can multiply both numerators and both denominators together. That's the same as 13 times sine of 32 degree over the sine of 68 degree. That's it. So it's a very simple law to use, right? So let me check out what that is. 13 sine 32 divided by sine 68. So 13 times sine 32 divided by sine 68. What is that equal to? It's equal to 7.429, so 7.43. So it is equal to 7.43. Let me see. What's my rounding? Using the sine rule, 2 decimal places. Yeah, 2 decimal places. So you know how particular math space is, okay, with everything. So make sure you answer the question fully. Actually, in math space, you should enter A equals, well, it's about, let's say equals 7.43, okay? That's how it likes the answer. All right, let's do a second example. Here we go. Find the value of x using the sine rule. It's a law of sine, okay? Math space call it the sine rule. It's a law of sine. All right, round your answer to 1 decimal places. Now we have an angle. Now we need an angle, okay? So let me see. What do I have? I have the length of the opposite side of the angle. Sorry, I have the length of the opposite side of the angle, and I'm given this pair right here of angle and opposite side, okay? So I'm going to use the law of sine right there. I have 15 divided by sine of the angle x equals what? Equals 19, the side, divided by the sine of 50 degree. Here we go. Now, hey guys, you should be able to solve that, I know. Check it out. It's sometimes useful to remember this very simple property right here. If you have an equality of two fractions, if a over b is the same as c over d, then this is the same as, you can flip both sides. b over a equals d over c, okay? If two fractions are equal, then their reciprocal are equal, of course, right? So I'm going to write sine x over 15 equals sine 50 degree over 19, and I could have started there, and therefore I multiply both sides by the 15 right here, and I have sine x equals sine 50 degree times 15 divided by 19. Now be careful, I need to find x right here, right? And so you know what we're going to do. We're going to do x equals sine minus 1, you know, on the calculator of this value right here, whatever that is. So sine of 50 degree times 15 over 19. All right, what is this value? You take your calculator, of course. All right, so what do we want? We want the sine minus 1, inverse sine, also called sine minus 1 of the sine of 50, right here, times 15, right there, divided by 19. You don't need to open and close more parentheses than that, okay? Let's check out the value of this angle, and this is 37.2 degree, and so we have x is about 37.2 degree, okay? So x is about 37.2 degree. Here we go. Let's do one last problem. Okay, here's one last problem. Calculate the length of y. Now y is just BC, okay? In meters using the sine rule, the law of sine. Express your answer correct to 1 decimal places. Okay, what's going on here? Y is the length. The opposite angle of y is right here. Oh, okay, I got everything again. I mean, this is really simple, right? So you write y over the sine of, well, the opposite angle is 11 degree, and that is supposed to be equal to 12 over the sine of 129 degree. So y is equal to 12 times sine 11 degree divided by the sine of 129 degree. Here we go. 12 sine 11 divided by sine 129. Let's see what that is. So we have 12 sine 11 divided by the sine of 129 right here. And the answer is, it's about 2.9. So this is about, y is about 2.9 meters. There is a unit, okay, be careful. All right, thank you for watching.